Hi guys, you are welcome once again to the Smart Way lectures. Now we are here to continue on chemistry, on organic chemistry. In our last video we talked about the elucidation of the structure of organic compound. We just talked about the separation and then the purification. We have looked at extensively how different samples based on different physical properties, different methods are used to purify them. Now once we get the purity out, the next one is to now go and do the elemental determination, or you have to go we do what's called the identification. We will go and identify the various elements within the organic compound. We go and identify the various elements within the organic compound. So basically, as we said earlier, that most organic compounds do contain some amount of what carbon, and again some amount of what hydrogen. So these are the elements that are basically in organic compounds. So anytime you are looking for organic compounds, please look at this element. They are always inside. Now, how do we, what procedure, what kind of test do we perform to identify that there is carbon in the sample? Remember, the sample we took was alcohol. We took alcohol sample. And we also took the hair. So please, let's be consistent with what we are doing. So that alcohol in the hair, this time around we can also take like methane. Okay, we can also take like some compound. Okay, anyhow you can take any element, but let's stick to this one. So once we take it, we have purified it. Now we are now going to look for carbon and hydrogen inside. Now this aspect is what we call the qualitative analysis. In the qualitative analysis, various elements are identified within the organic sample. Now, how is it done? Very simple. How is it done? Very, very simple. So quickly, now this is what we do. First, what you do is that the sample that you took, the dry mass of the sample, once after the purification, the dry sample is then, so the dry sample, what is the dry pure sample? Okay, as the dry pure sample. So the dry pure sample is oxidized or burned in excess oxygen. The dry sample, is oxidized or burned in excess oxygen, or with what I call the oxidizing agent. Now in the process, because we are looking for carbon and the hair, and also we are looking for hydrogen, what basically will happen is that we'll burn this one in air, like in excess oxygen, so, or otherwise with an oxidizing agent. So we burn this one with oxygen, you burn it. I'm talking of normal burning, otherwise called combustion, or otherwise called oxidation. So you oxidize the organic sample, you oxidize the pure organic sample, the pure mass of the organic sample. You oxidize the pure mass of the organic sample, in with some oxidizing agent, or in oxygen. Now once you do that, what basically will happen is that the carbon that is present inside is converted to something that is carbon dioxide, and the hydrogen is also then converted to water vapor. So you have gas coming out from the reaction, two gases coming out from the reaction. This gas in the form of a liquid, to form of a vapor, that is a vapor. And so this is what we call the combustion or the oxidation. This reaction is called the combustion reaction. or what we call the oxidation reaction. So the pure mass of the organic sample, that is it. So the pure mass of the organic sample, or the pure organic sample, is burned in excess oxygen, and so that the carbon, okay, is converted to carbon dioxide. Okay, carbon is converted to carbon what? Dioxide. So this is carbon dioxide here. So you have carbon what? Dioxide. Okay, so you have carbon dioxide here. So carbon dioxide. So the CO will be converted to carbon dioxide, and then the CO will be converted to carbon dioxide, and then the hydrogen will be converted to what? To water. Okay, so you have water here, you have water here, inside there. Now once you have converted it, what mean is that you have to look for whether truly there is carbon inside. Now how do you look for carbon? The carbon has been converted to what? Carbon dioxide, and hydrogen has been converted to water. So what you can do is simply that you just test for the presence of carbon dioxide, and also test for the presence of what? Of water within the what? Within the reaction vessel. So what do? You test for the carbon dioxide. Now once you test and there's a carbon dioxide there, it means that automatically there's carbon inside the sample, because it is the carbon that we are looking for. But the carbon dioxide has been converted to, the carbon within the sample has been converted to what? Carbon dioxide. The hydrogen has also been converted to water. So let's look for carbon dioxide and then confirm that there's what? Carbon inside. So quickly, what you do, you pass the what? A gas. Okay, you react the carbon dioxide that has come out. Okay, you react the carbon dioxide that has come out. Okay, you do what's called a chemical test. So the chemical, you react it with what we call lime water. Okay, so you react with what we call lime water. Okay, this is lime water. Calcium hydroxide is lime water. So this is lime water. So you add the lime water, or you react the gas carbon dioxide with lime water. The lime water is usually colorless. And what happened? Once the carbon dioxide come into the presence of this one, the formation, there will be a formation of calcium carbonate. Okay, there will be a formation of calcium carbonate and water. Now the whole resulting what? Mixture, that is the resulting mixture, will be milky. Or otherwise chalky. Okay, so it will be milky or what? Chalky. Now once you see or you observe the milky color change, that is from the colorless solution turns to milky color, that means that carbon dioxide is present. That means carbon dioxide or CO2 is what? Present. Now that is carbon dioxide or CO2 is present. Once carbon dioxide is present, it also means that carbon atom, that is the carbon that we are looking for within the sample, is also present. So in that case, we have what? Confirm the presence of carbon within the sample. By confirming the presence of carbon dioxide, you confirm the sample. Are you okay with that? Very simple. So we are looking for carbon dioxide, but we've converted the carbon dioxide to what? To CO2. Let's look for CO2, whether there's CO2 inside. The gas that comes out as CO2 is reacted with what? Lime water, and that turns into what? Milky color. The colorless color, that is the colorless, okay, lime water will change to milky color, and that confirms the presence of carbon dioxide and also confirms the presence of what? Carbon within them. That means that the sample that you took, so if it is your hair, if it is our hair, this is what will happen. If it is alcohol, that is what will happen. So basically that is what is happening. Now let's also go and confirm the presence of hydrogen inside. How do we confirm the presence of hydrogen? Very, very simple. Now what do we do? Now there is something that we use here. Okay, let me go back. So good. So let's confirm the presence of water. Okay, so here confirm the presence of water. For the presence of water, the water vapor that will come out is also reacted. The gas water vapor that comes out is also reacted with white anhydrous with white anhydrous, okay, white anhydrous, okay, copper 2 tetraozosulfate 6, okay, copper 2 tetraozosulfate 6. So water, okay, will react with the white anhydrous copper 2 tetraozosulfate 6. Look at the color, white anhydrous copper 2 tetraozosulfate 6. Now once that comes out, once the water combined with the anhydrous means that the absence of water, and that what happens is that the water will go and surround this kind of salt, okay, it will surround this chemical, it will be hydrated, okay, this compound, this anhydrous, okay, substance will be, or compound will be hydrated, and in that time the white color, okay, will change to, okay, a blue color. The blue color will confirm the presence of what? Water. And the compound that will be formed is this. That is the copper 2 tetraozosulfate 6. That is, it will be hydrated. So you can say that 5 maybe water molecules would have added or would have surrounded the that, and then you put 5 over here because 5, you've added 5, so 5 over here. So this is what we call the chemical test. This is what we call the chemical test for water. So by testing for water, you are indirectly testing for what? Hydrogen, because hydrogen in the air or in the organic sample is converted to water. So you are testing for water, so therefore you are testing for the presence of the air inside the organic sample. So this is the test that we run to identify the carbon or hydrogen within the sample that we take. In a nutshell, the pure dry organic sample is combusted or heated or burned in excess oxygen. All carbon present is converted to carbon dioxide, hydrogen converted to water, and the carbon dioxide is reacted with what? Lime water, and the presence of milky color confirms the presence of carbon dioxide and also confirms the presence of carbon within the carbon dioxide, and that means that the sample contains carbon, the carbon atom. And also to do that, the water is also the same. The water that is converted out is reacted with white anhydrous copper 2 tetraozosulfate 6. Now when that happens, when that happens, let me zoom in here. Okay, so when that happens, the white anhydrous copper 2 tetraozosulfate 6, okay, the white anhydrous copper 2 tetraozosulfate 6 will quickly be change color to blue. Now copper ions will be produced within the system, so that will change the color to blue, and that will confirm the presence of that. So basically, this is what we call the elemental determination. Some other people will say the qualitative analysis, but it's all the same. So basically, that is what we have here. Okay, very, very simple. Chemistry is very, very, very simple. Now in our next lectures, we'll be talking about the elemental, we'll be talking about the percentage determination. We'll look at the percentage determination here. We'll be looking at the percentage determination. Now that we have identified that there's carbon and hydrogen within the organic sample, we are going on to know what are the percentages of the elements that are there. Once we know the percentages, then we now begin to find their formula. So anytime we write the chemical formula, you know where it comes from. So that will end the lesson for today. Thank you very much.